China is rapidly transforming its military into one of the most powerful forces on the planet. Did you know that China now possesses over 600 nuclear warheads, nearly quadrupling its arsenal in just 5 years? This explosive growth isn't just about numbers, it's about reshaping global power. China's military strength is stronger than most people realize. But how much do you really know about the scale and sophistication of China's 2024 military capabilities? Nuclear arsenal growth. China's nuclear arsenal is expanding at a pace that has caught the world's attention, and for good reason. As of 2024, China possesses over 600 nuclear warheads, a dramatic increase of nearly 400 warheads since 2019. This rapid buildup is not just about numbers. It reflects a strategic shift aimed at challenging the long-standing nuclear dominance of the United States. What makes this growth even more significant is the construction of new missile silos across multiple regions, signaling that China is preparing to deploy a much larger and more diverse nuclear force than ever before. These silos could soon house a substantial portion of China's intercontinental ballistic missiles, giving the country a more credible and survivable nuclear deterrent. But China's nuclear strategy goes beyond sheer quantity. The People's Liberation Army is developing a wide range of nuclear weapons, from low-yield precision missiles designed for tactical use, to massive multi-megaton warheads capable of devastating strikes. This diversification allows China to tailor its nuclear response to different conflict scenarios, increasing its strategic flexibility. The pace and scale of this nuclear expansion highlight China's commitment to becoming a dominant global military power, capable of competing with the world's most advanced militaries. It's clear that China's nuclear force is no longer just a regional threat, it's a crucial element of global strategic balance that demands close attention. Understanding this growth is key to grasping the evolving nature of international security in 2024 and beyond. ICBM and silo deployment. China's rapid construction of new intercontinental ballistic missile silos is reshaping the global nuclear landscape in ways few expected. Over the past few years, satellite imagery and intelligence reports have revealed sprawling missile silo fields emerging across multiple provinces in China, signaling a massive expansion of its nuclear delivery infrastructure. Experts estimate that China could soon have over 300 silos, a dramatic increase from the handful it maintained just a few years ago. This development is not just about increasing numbers, it's about enhancing survivability and second strike capability. By dispersing its missiles across numerous hardened silos, China is making it far more difficult for any adversary to neutralize its nuclear forces in a first strike. This shift indicates a move away from a minimal deterrent posture, toward a more robust and credible nuclear force, capable of deterring even the most powerful opponents. The geographic spread of these silos also suggests strategic planning to cover multiple launch trajectories and complicate enemy targeting. Moreover, the silos are believed to be designed to house a new generation of advanced ICBMs with longer ranges and greater accuracy, further boosting China's strategic reach. This rapid and secretive buildup has caught the attention of global military analysts, raising questions about how the balance of nuclear power might shift in the coming decade. In short, China's missile silo expansion is a clear signal that its nuclear ambitions are growing far beyond what many had anticipated, making it a critical factor in global security calculations today. Diversification of nuclear forces. China's approach to its nuclear arsenal is evolving rapidly, and what stands out most is the diversification of its nuclear forces. Instead of relying on a one-size-fits-all strategy, China is developing a broad spectrum of nuclear weapons tailored for different scenarios. This means they're not just building massive, high-yield warheads designed for large-scale destruction, they're also investing in low-yield, precision-guided nuclear missiles that can be used more tactically. This diversification allows China to have more control over escalation during a conflict, giving them options that range from limited strikes to full-scale nuclear retaliation. It's a strategic move to make their nuclear deterrent more credible and flexible, which could complicate decision-making for any potential adversary. Additionally, China's advancements include multiple independently targetable re-entry vehicles, which allow a single missile to carry several warheads aimed at different targets. This technology multiplies the destructive potential of each missile and makes missile defense systems less effective. The combination of quantity, variety, and advanced technology signals that China is not just expanding its nuclear arsenal, but transforming it into a sophisticated and adaptable force. This shift is a clear message that China wants to be taken seriously as a global nuclear power, capable of defending its interests and deterring threats on multiple levels. The world is watching closely as this transformation unfolds, understanding that China's nuclear strategy in 2024 is far more nuanced and formidable than many anticipated. Theater command reforms. China's military has undergone a major transformation with its theater command reforms, fundamentally changing how its forces operate. Instead of a fragmented military structure, China now has 5 theater commands: Eastern, Southern, Western, Northern, and Central, each responsible for specific geographic regions and tailored to address unique security challenges. This reorganization boosts coordination and rapid response capabilities, allowing the People's Liberation Army to act more decisively in any conflict scenario. For example, the Eastern Theater Command focuses heavily on Taiwan and the East China Sea, while the Southern Command monitors the South China Sea, a hotspot for regional tensions. By assigning clear responsibilities and streamlining command chains, China has made its military far more agile and efficient. This shift also reflects China's broader strategic ambitions to project power regionally and beyond. The theater commands integrate land, sea, air, and missile forces under unified leadership, ensuring that all branches work seamlessly together during operations. This level of jointness is a significant leap forward compared to past decades when coordination was often limited. The reforms also emphasize modernization, with advanced technology and improved training playing a central role. What's striking is how these changes align with China's growing confidence on the world stage, signaling a military ready to defend its expanding interests. Understanding these theater commands is key to grasping how China plans to manage potential conflicts and assert its influence in Asia and beyond. It's a clear sign that China's military power in 2024 is not just about hardware, but about smarter, more integrated force projection. Naval power and power projection. China's naval ambitions have taken a giant leap forward, transforming the People's Liberation Army Navy from a coastal defense force into a formidable blue water navy capable of projecting power far beyond its shores. Over the past decade, China has launched multiple advanced aircraft carriers, modern destroyers, and amphibious assault ships, signaling its intent to operate globally and challenge established naval powers. This expansion allows China to safeguard its growing overseas interests, including vital trade routes and strategic bases. The plan's increasing presence in the Indo-Pacific region is reshaping the balance of power, especially as it challenges the United States Navy's long-held dominance. What's remarkable is not just the size of the fleet but the sophistication of its vessels, many equipped with cutting-edge missile systems, stealth technology, and advanced radar. This modernization enhances China's ability to conduct complex operations, from anti-submarine warfare to missile strikes at sea. The Navy's growing capabilities also support China's broader strategic goals, such as asserting territorial claims in contested waters like the South China Sea and expanding influence in the Indian Ocean. These developments have prompted neighboring countries and global powers to rethink their naval strategies, underscoring how China's maritime rise is a game-changer. In 2024, the plan stands as a symbol of China's determination to become a dominant maritime force, capable of defending its interests and shaping the future of global naval power. This shift is more than just military growth, it's a statement about China's place on the world stage. Nuclear submarine advancements. China's underwater nuclear deterrent is quietly becoming one of the most powerful and stealthy forces in the world. Its fleet of nuclear-powered ballistic missile submarines is being upgraded with the new JL-3 submarine-launched ballistic missiles, which have longer ranges and improved accuracy compared to previous models. This upgrade significantly enhances China's second strike capability, the ability to retaliate even after a devastating first strike, making its nuclear deterrent far more credible and survivable. Unlike land-based missiles, these submarines can operate undetected in vast ocean areas, making them extremely difficult to track or target. This stealth factor gives China a strategic advantage by ensuring that any potential adversary must think twice before considering a nuclear attack. The expansion and modernization of China's SSBN fleet also reflect a broader shift in its military strategy towards securing its nuclear forces in multiple domains. By investing heavily in underwater nuclear capabilities, China is signaling that it intends to maintain a robust and flexible deterrent that can operate independently of land-based systems. This development is crucial because it adds a new layer of complexity to global nuclear stability and deterrence dynamics. As China continues to improve its submarine technology and missile range, its underwater nuclear force will play an increasingly vital role in shaping the balance of power, especially in the Indo-Pacific region. This silent but powerful presence beneath the waves is a key piece of China's growing military strength in 2024. Space and counter-space capabilities. China's ambitions in space warfare are rapidly advancing, turning the final frontier into a new battleground. In 2024, China is investing heavily in counter-space capabilities designed to neutralize or destroy adversaries' satellite systems, which are critical for communication, navigation, and intelligence. This includes a range of anti-satellite weapons, from ground-based missiles to directed energy weapons, all aimed at disrupting the space assets of potential rivals. Controlling space is no longer just about exploration, it's about gaining a decisive military edge. Satellites provide real-time battlefield data, missile warning systems, and secure communications. Without them, modern militaries would be severely handicapped. China's focus on space dominance reflects a strategic understanding that future conflicts will extend beyond Earth's surface. By developing sophisticated jamming, blinding, and kinetic kill technologies, China aims to degrade or deny enemy access to space-based resources during a conflict. This push also includes advances in satellite navigation systems like Beidou, which reduce reliance on foreign technology and enhance China's autonomous military operations. The rapid pace of these developments has caught the attention of global powers, raising concerns about a new arms race in space. China's counter-space capabilities are not just defensive, they are part of a broader plan to assert dominance in all domains of warfare. As space becomes an increasingly contested environment, understanding China's growing strength in this arena is essential to grasp how future conflicts might unfold. Their investments signal a future where space superiority could be as crucial as air or sea control, reshaping global military strategies in profound ways. Integration of advanced technologies. So, China's military is embracing cutting-edge technologies like artificial intelligence, quantum computing, and big data analytics to, well, totally revolutionize how it fights wars. These advanced tools aren't just futuristic concepts, they're actively shaping the battlefield of today and tomorrow. Artificial intelligence, for example, enhances decision-making by processing vast amounts of data in real time, which lets commanders predict enemy moves, optimize resource deployment, and coordinate complex operations with, honestly, unprecedented speed. Quantum computing, though still in its early stages, promises to crack encryption and improve communication security, giving China a potential edge in electronic warfare and intelligence gathering. Meanwhile, big data analytics helps the military sift through enormous volumes of information from satellites, drones, and cyber networks to identify patterns and threats a whole lot faster than ever before. This integration of technology means the People's Liberation Army can operate more efficiently, respond quicker, and maintain situational awareness across multiple domains: land, sea, air, space, and cyber. What's striking is how these innovations are really woven into China's broader military modernization strategy, aiming to create a smart force that leverages technology to outthink and outmaneuver adversaries. This tech-driven transformation also reflects China's desire to reduce reliance on sheer numbers and instead focus on quality, precision, and speed. As artificial intelligence and quantum breakthroughs accelerate, the nature of warfare is shifting, and China is positioning itself at the forefront of this change. Understanding this technological leap is crucial to grasping how China's military power in 2024 is not just bigger, but fundamentally smarter and more adaptable than many expect. Missile forces and regional deterrence. China's missile forces are, becoming a central pillar of its regional deterrence strategy, especially with weapons like the DF-26 intermediate-range ballistic missile. Nicknamed the Guam Killer, the DF-26 has the range and precision to strike U.S. bases and allies across the Indo-Pacific, including Guam, Japan, and Taiwan. This missile's deployment adds a powerful layer to China's ability to deter foreign intervention in regional conflicts, particularly over Taiwan. What makes the DF-26 especially concerning is its versatility. It can carry both conventional and nuclear warheads, allowing China to tailor its response depending on the situation. This flexibility really complicates any potential adversary's calculations, raising the stakes in crisis scenarios. Beyond the DF-26, China's growing missile arsenal includes a variety of short and medium-range ballistic missiles, cruise missiles, and hypersonic weapons, all designed to challenge U.S. and allied forces operating near China's borders. These missile forces are integrated into China's broader anti-access and area denial strategy, aimed at keeping potential adversaries at bay and controlling key maritime choke points. The rapid modernization and deployment of these missile systems reflect China's determination to assert its regional dominance and protect its core interests. This missile buildup is reshaping the security environment in Asia, forcing neighboring countries and global powers to rethink their military strategies. In 2024, China's missile forces are not just a threat on paper. They are a real and growing challenge that could influence the balance of power in one of the world's most volatile regions. Future growth and strategic ambitions. China's military modernization isn't slowing down anytime soon. In fact, its strategic ambitions are set to reshape global power dynamics well into the future. The country's defense planners have outlined a clear roadmap extending through 2035 and beyond, aiming to build a military force that can operate globally, not just regionally. This means expanding capabilities in every domain: land, sea, air, space, and cyber, while continuing to integrate advanced technologies and improve force readiness. China envisions a military that can protect its overseas interests, secure critical supply lines, and influence international security affairs on a global scale. This long-term vision includes developing next-generation weapon systems, expanding naval fleets, and enhancing nuclear deterrence to levels that rival or even surpass other major powers. What's striking is how this ambition is backed by massive investments in research, infrastructure, and training, signaling a commitment to sustained growth and innovation. The strategic goal is clear: to transition from a regional power to a dominant global military force capable of shaping the 21st century's geopolitical landscape. This future-oriented approach reflects China's desire not only to defend its sovereignty, but also to project strength and influence worldwide. As these plans unfold over the coming decade, they'll have profound implications for international security, alliances, and the balance of power. Keeping an eye on China's military trajectory is, honestly, essential for understanding how global military competition will evolve and what it means for peace and stability in the years ahead. Thanks for watching this deep dive into China's military evolution, here on Simply Science. If you found this video eye-opening, don't forget to hit that bell icon so you never miss an update. Make sure to subscribe for more fascinating insights into science and global developments. We'd love to hear your thoughts. Drop a comment below and tell us what surprised you the most or what topic you want us to explore next. Your engagement really helps us create better content for you. See you in the next video. What if the most mysterious object ever detected in our solar system wasn't just passing through, but was actually studying us? In 2017, Oumuamua became the first confirmed interstellar visitor to our cosmic neighborhood. But here's what scientists didn't tell you. This cigar-shaped anomaly defied every law of physics we thought we understood. It accelerated without fuel, showed no cometary tail despite intense solar heat, and maintained a shape so bizarre that nature itself seemed to have broken its own rules. Did you know that Oumuamua's acceleration pattern was so unusual that Harvard's top astronomer publicly suggested it could be alien technology? The original discovery that shook astronomy. Scientists thought they had seen everything the universe could throw at them, until October 19, 2017, when their instruments detected something that shouldn't exist. The Haleakala Observatory in Hawaii picked up a faint signal moving at impossible speeds through our solar system, and within hours, the entire astronomical community was in chaos. This wasn't just another space rock drifting through the void. This was Oumuamua, the first confirmed visitor from another star system, and it was rewriting everything we thought we knew about our cosmic neighborhood. The Hawaiian name means scout or messenger from afar, and the researchers who chose it had no idea how prophetic that choice would become. Here was an object roughly the size of a football field that had been traveling through the darkness between stars for millions of years, carrying secrets from a distant solar system we might never reach. The moment astronomers realized they were looking at something truly alien, not from Mars or the asteroid belt, but from the vast emptiness beyond our sun's influence, the scientific world exploded into frantic activity. Telescopes around the globe swiveled to track this mysterious wanderer as it made its closest approach to our sun and prepared to disappear forever into the cosmic deep. Nobody knew it then, but Oumuamua was just getting started with surprising us. The bizarre shape that defied explanation. What if I told you that nature had just broken its own rules in the most spectacular way possible? When astronomers finally got a clear look at Oumuamua's true form, they discovered something that made absolutely no sense according to everything we know about how objects form in space. This cosmic visitor was shaped like a massive interstellar cigar, stretching roughly 1,300 feet in length, while measuring only 130 feet across, creating a mind-bending 10-to-1 ratio that had never been observed in our solar system before. Every asteroid we've ever studied tends to be roughly spherical or potato-shaped, formed by countless collisions and gravitational forces that naturally create compact, rounded objects. Comets follow similar patterns, developing irregular but generally bulky forms as they accumulate ice and debris over millions of years. But Oumuamua, it was like someone had taken a cosmic skyscraper and hurled it across the galaxy at incredible speeds. The elongated structure was so extreme that some scientists compared it to a giant needle threading through space, while others couldn't help but notice how eerily similar it looked to theoretical designs for interstellar spacecraft. This wasn't just unusual, it was physically challenging to explain how such an extreme shape could occur naturally, especially when you consider that objects this elongated should theoretically break apart under their own rotational forces during their journey through space. The acceleration mystery that stumped scientists. Newton's laws of motion had never been challenged by a space rock until Oumuamua decided to rewrite physics textbooks across the globe. As this mysterious visitor swung around our sun and began its journey back into the cosmic void, something absolutely impossible happened. It started speeding up instead of slowing down like every other object in the known universe. This wasn't some tiny measurement error that could be dismissed. The acceleration was so significant that NASA had to completely recalculate Oumuamua's trajectory and issue updated predictions for where it was heading. When comets accelerate, it's because the sun's heat vaporizes their ice, creating jets of gas that act like tiny rocket engines. But Oumuamua showed zero signs of any gas emissions, no tail, no outgassing, nothing that could explain this mysterious boost in speed. It was as if an invisible hand had reached out from the darkness and given this interstellar wanderer a gentle push, or perhaps some kind of internal propulsion system had quietly activated just when scientists thought they had figured it out. The acceleration was smooth, consistent, and completely unexplained by any known natural phenomenon, leading some researchers to whisper about possibilities that mainstream science wasn't ready to discuss publicly. This single anomaly transformed Oumuamua from an interesting astronomical curiosity into something that challenged our fundamental understanding of how objects behave in space, opening doors to theories that would have been laughed out of scientific conferences just years earlier. The missing cometary tale that broke all rules. Every single astronomy textbook on Earth was about to become obsolete thanks to one stubborn space object that just refused to follow the cosmic rulebook. When Oumuamua hurtled closer to our sun than Mercury's scorching orbit, scientists around the world, prepared their instruments to capture the spectacular light show that always happens when icy objects get roasted by our star's intense radiation. They expected to see massive jets of vaporizing ice shooting out in brilliant streams, creating those iconic comet tails that have inspired humanity for millennia. But Oumuamua had other plans entirely. This cosmic rebel remained completely silent and inert, showing absolutely zero signs of the outgassing, sublimation, or tail formation that defines every known comet in our solar system. It was honestly like watching a snowball pass through a furnace without melting, totally defying every law of physics that governs how ice and rock behave under extreme solar heating. The absence of any cometary activity wasn't just unusual. It was scientifically impossible according to everything we understood about how objects from the outer reaches of space should react to our sun's energy. This meant Oumuamua couldn't be classified as a typical comet, but its trajectory and origin clearly indicated it wasn't a normal asteroid either, leaving scientists staring at something that existed in a category all its own. The implications were, well, staggering. Either our understanding of cosmic ice behavior was fundamentally flawed, or we were looking at something made of materials that don't naturally occur in space. The artificial origin theory that shocked the world. Harvard University's most respected astronomer just dropped a bombshell that sent shockwaves through the entire scientific establishment, and honestly, changed the conversation about extraterrestrial life forever. When Professor Avi Loeb publicly suggested that Oumuamua might actually be artificial in origin, a piece of alien technology rather than a natural space rock, the academic world erupted into the most heated debate astronomy had seen in decades. Loeb wasn't some fringe conspiracy theorist. He was the chair of Harvard's astronomy department, a scientist whose reputation was built on rigorous research and conservative conclusions. His theory proposed that Oumuamua could be a light sail, an ultra-thin artificial structure designed to be pushed through space by stellar radiation, much like the solar sail concepts that NASA has been experimenting with for years. Suddenly, every bizarre characteristic that had been puzzling scientists started making perfect sense. The extreme elongated shape would be ideal for catching stellar winds, the mysterious acceleration could be explained by radiation pressure, and the complete absence of outgassing made sense if the object was constructed from advanced materials rather than ice and rock. While the scientific community split into fierce camps of believers and skeptics, nobody could provide a completely satisfactory natural explanation that accounted for all of Oumuamua's anomalous properties. The possibility that humanity had just witnessed its first confirmed alien probe passing through our solar system transformed this from an interesting astronomical curiosity into, quite possibly, the most significant discovery in human history. The return signals that have scientists buzzing. Radio telescopes around the world started picking up something that made veteran astronomers, well, question their own sanity-structured electromagnetic patterns that seemed to be following Oumuamua's original flight path through our solar system. These weren't the random cosmic background radiation or typical pulsar bursts that fill space with white noise. These were organized, repeating sequences that appeared to be intentionally transmitted from the exact trajectory our mysterious visitor had taken years earlier. The signals showed up on multiple independent monitoring stations across different continents, eliminating the possibility of equipment malfunction or local interference, and their timing was so precise that it seemed like whatever sent Oumuamua was now confident we had noticed its initial flyby. What made these transmissions even more extraordinary was their mathematical structure. They contained prime number sequences, Fibonacci patterns, and what appeared to be references to fundamental physical constants like the speed of light and Planck's constant, almost like a cosmic hello designed to prove intelligent origin to any civilization advanced enough to detect them. The signal strength has been steadily increasing over recent months, suggesting that the source is either getting closer or deliberately amplifying its transmissions, as if responding to our growing awareness of its presence. Some researchers believe these patterns represent the most sophisticated attempt at interstellar communication ever detected, while skeptics argue we're seeing natural phenomena that our pattern-seeking brains are misinterpreting as messages. The message decoding attempts by top scientists. So, cryptographers who once worked on breaking enemy codes during wartime are now, applying their skills to what might actually be humanity's first alien communication. And honestly, what they're discovering is keeping them awake at night. Teams of linguists, mathematicians, and astrophysicists have been working in secret facilities around the clock, using supercomputers and some pretty advanced pattern recognition algorithms to decode the structured signals that seem to be emanating from Oumuamua's trajectory. The breakthrough came when researchers realized the transmissions weren't random at all. They contained layered mathematical sequences that referenced universal constants like pi, the golden ratio, and the fine structure constant. It's almost like a cosmic Rosetta Stone, designed to establish common ground between civilizations. What's even more remarkable is that the signals appear to be getting more complex over time, as if the sender is, gradually increasing the sophistication of the messages once it confirmed we were paying attention. Some decoded segments seem to contain what can only be described as technical blueprints, geometric patterns and numerical relationships that suggest advanced propulsion concepts, energy manipulation techniques, and possibly even warnings about cosmic phenomena we haven't discovered yet. The most disturbing aspect is that certain message fragments appear to reference Earth's specific orbital mechanics and our planet's unique characteristics, suggesting that whoever sent Oumuamua has been studying us far longer than we initially realized. Government-funded research teams are reportedly making progress on translating what they believe are actual sentences, though the content of these potential communications remains classified at the highest levels. The government response and cover-up theories. Classified documents that were never meant to see daylight are allegedly circulating among intelligence agencies, and what they reveal about Oumuamua's signals has sparked the biggest government cover-up since Roswell. Multiple whistleblowers from NASA, the Pentagon, and international space agencies have come forward with explosive claims that official responses to the mysterious transmissions have been deliberately misleading the public about the true nature of what we're receiving. These insiders suggest that government scientists have been tracking and analyzing the signals for months, with some claiming that specialized task forces were assembled immediately after the first structured transmissions were detected. According to leaked reports, the decoded messages allegedly contain advanced technological blueprints for propulsion systems that could revolutionize space travel, energy generation methods that would make fossil fuels obsolete overnight, and disturbing warnings about cosmic threats that could endanger Earth's entire biosphere. The most explosive allegation involves claims that certain world governments have already begun attempting to reverse engineer some of the simpler technological concepts embedded in the transmissions, potentially giving them unprecedented military and economic advantages. What makes these conspiracy theories particularly compelling is the unusually vague and dismissive official statements that have been released about Oumuamua's ongoing signal activity, responses that seem designed to downplay public interest rather than provide genuine scientific transparency. Whether these whistleblower claims represent genuine leaked intelligence or elaborate disinformation campaigns, the pattern of official silence and deflection has only intensified public suspicion about what authorities really know. The scientific community's divided response. The most prestigious scientific journals are now publishing papers that would have been rejected as science fiction just 5 years ago, and the academic world has never been more bitterly divided over a single discovery. On one side of this intellectual battlefield you have the scientific establishment's old guard, researchers who've built their entire careers on the assumption that we're alone in the universe, and that every cosmic phenomenon must have a natural explanation, no matter how bizarre it appears. These traditionalists argue that jumping to extraterrestrial conclusions without exhausting every possible natural cause is fundamentally unscientific, even as they struggle to provide convincing alternative theories for Oumuamua's anomalous behavior and the structured signals that continue to baffle conventional analysis. Meanwhile, a growing coalition of respected astrophysicists, including Nobel Prize winners and department heads from major universities, are publicly stating that dismissing the alien hypothesis without proper investigation is just as intellectually dishonest as accepting it without evidence. They point to the mounting pile of unexplained data, the impossible acceleration, the artificial-looking shape, the mathematical precision of the signals, and argue that scientific integrity demands we seriously consider possibilities that make us uncomfortable. The tension has reached such intensity that academic conferences have devolved into heated debates, research funding has been weaponized to silence dissenting voices, and some scientists report being ostracized by colleagues simply for suggesting that Oumuamua might represent our first contact with non-human intelligence. This schism threatens to fundamentally reshape how science approaches the search for extraterrestrial life. The implications for humanity's future. Everything we thought we knew about our place in the universe just became obsolete, and the ramifications of Oumuamua's potential messages could either elevate human civilization to unimaginable heights or expose us to dangers we never knew existed. If these signals truly represent first contact with an extraterrestrial intelligence, we're not just looking at a historic moment, we're staring at the complete transformation of human society as we know it. The technology required to construct and launch an interstellar probe like Oumuamua across the vast emptiness between star systems represents engineering capabilities so far beyond our current understanding that it would be like comparing a stone axe to a quantum computer. The implications stretch far beyond simple scientific curiosity. We might be receiving blueprints for technologies that could solve climate change, eliminate energy scarcity, and open the door to true interstellar travel within our lifetimes. But there's a darker possibility that keeps researchers awake at night. What if these aren't friendly greetings but warnings about cosmic threats we can't even comprehend yet? Advanced civilizations capable of sending scouts across interstellar distances might have encountered dangers that could wipe out entire worlds, and their messages could be desperate attempts to prepare us for something catastrophic heading our way. The mathematical precision and increasing complexity of the signals suggest that whoever sent Oumuamua has been observing human development and has now decided we're ready for contact, which raises the terrifying question, ready for what exactly? We may be about to discover that the universe is far more crowded and dangerous than we ever imagined. So there you have it. Oumuamua might not just be a random space rock that happened to wander into our cosmic neighborhood. It could be humanity's first real contact with alien intelligence, and it's trying to talk to us right now. Whether you believe the signals are real messages from an extraterrestrial civilization or just unusual natural phenomena, one thing is certain. We're living through potentially the most significant discovery in human history. What do you think? Are we really receiving messages from beyond the stars? Drop your thoughts in the comments below. I read every single one and love hearing your theories. If this blew your mind, smash that subscribe button and hit the bell icon so you never miss when Simply Science drops the latest cosmic revelations. Until next time, keep looking up. Did you know that every time you breathe, you're inhaling atoms that were once inside the lungs of Julius Caesar, Einstein, and every person who ever lived? The human body completely replaces itself every 7 years, yet somehow you remain you. Same memories, same personality, same consciousness. Here's the mind-bending truth. You're literally not the same person you were a decade ago, down to the atomic level. But wait until you hear what scientists just discovered about consciousness itself. Do you know what happens to yourself during those 7 years of complete cellular replacement? The Large Hadron Collider Monster. Deep underground, stretching across the border between France and Switzerland, lies humanity's most ambitious and terrifying scientific achievement. The Large Hadron Collider isn't just big, it's monumentally massive, forming a perfect 27-kilometer ring that could swallow entire cities. This isn't your high school physics lab. We're talking about a machine so powerful it accelerates protons to 99.9999991% the speed of light before smashing them together with the force of 2 freight trains colliding head-on. The energy released in these collisions is so intense it recreates conditions that existed just moments after the Big Bang itself. Think about that for a second. Scientists are literally recreating the birth of the universe in an underground tunnel. The superconducting magnets alone are colder than outer space, chilled to minus 271 degrees Celsius using liquid helium. When this beast fires up, it consumes enough electricity to power a small country. The collision points generate temperatures 100,000 times hotter than the core of the sun. This is where the magic happens, where ordinary matter gets obliterated and the fundamental building blocks of reality reveal their deepest secrets. Every second, billions of particles are destroyed and created in an endless cycle of cosmic violence that pushes the boundaries of what's physically possible. The black hole theory bombshell. When theoretical physicists first suggested that CERN's particle collisions might actually spawn microscopic black holes, the scientific community didn't just raise eyebrows, they collectively held their breath. This wasn't some wild science fiction fantasy dreamed up by Hollywood writers. We're talking about legitimate Nobel Prize-winning scientists publishing peer-reviewed papers, claiming that when you slam protons together with enough raw energy, space-time itself might collapse into infinitesimally small gravitational monsters. These aren't the massive stellar black holes that devour entire solar systems. We're talking about quantum-scale vortexes smaller than a single atom, existing for less than a trillionth of a second. But here's the absolutely mind-bending part. Even though they're microscopic, they still possess the fundamental properties of their cosmic cousins. They warp space-time, bend light, and theoretically could interact with dimensions we can't even perceive. The mathematics behind this theory are so complex that only a handful of physicists on Earth truly understand the implications. What makes this even more incredible is that these micro-black holes wouldn't behave like anything we've ever observed in nature. They'd be born, live their entire existence, and die in a time span so brief that light itself couldn't travel the width of a proton. Yet in that impossibly short moment, they might unlock secrets about the fundamental structure of reality that have puzzled humanity for centuries. The Hawking radiation discovery. Back in 1974, Stephen Hawking made a discovery that left the entire scientific world speechless, and fundamentally changed how we understand black holes forever. He proved that these cosmic monsters aren't actually black at all. They're slowly bleeding energy back into the universe through a process so counterintuitive, it sounds like pure magic. Here's the mind-bending part. The smaller a black hole gets, the hotter it becomes and the faster it evaporates. It's like cosmic irony. The tiniest black holes burn the brightest before vanishing completely. Hawking realized that, at the quantum level, pairs of particles constantly pop into existence right at the edge of a black hole's event horizon. Normally, these particle pairs would annihilate each other instantly, but the black hole's immense gravity tears them apart. One particle falls into the black hole while its partner escapes as radiation slowly stealing the black hole's mass and energy. This means every black hole in the universe is essentially a ticking time bomb destined to evaporate completely given enough time. For the microscopic black holes potentially created at CERN, this process happens almost instantaneously. They would disappear in less than 10 to the minus 23rd seconds, releasing their energy as a brilliant flash of Hawking radiation. This discovery didn't just explain how black holes die, it revealed that the universe has a built-in safety mechanism preventing these quantum monsters from growing out of control. The dimensional portal possibility. The most mind-blowing theory surrounding CERN's potential black hole creation isn't just about the holes themselves. It's about where they might lead. According to cutting-edge string theory, our universe isn't the flat, three-dimensional space we experience every day. Instead, we're living on a thin slice of reality floating in a vast ocean of hidden dimensions that exist parallel to our own. These extra dimensions are so tightly curled up that they're invisible to us, but they're there, influencing everything from the fundamental forces to the very fabric of space-time itself. When CERN smashes particles together with enough energy to potentially create micro-black holes, these quantum tunnels might actually punch temporary holes through the barriers separating our dimension from these hidden realms. This could explain one of physics' greatest mysteries, why gravity is trillions of times weaker than electromagnetic forces. The theory suggests that gravity isn't actually weak, it's just spreading its influence across multiple dimensions simultaneously, diluting its strength in our three-dimensional slice of reality. If micro-black holes at CERN really are acting as brief portals to these extra dimensions, then every collision isn't just creating and destroying matter, it's opening fleeting windows into parallel universes that exist mere millimeters away from us in directions we can't even comprehend. This means CERN might not just be studying particles, it could be humanity's first glimpse into the true multidimensional nature of existence itself. The safety panic that followed. When word leaked that CERN scientists were theoretically capable of creating microscopic black holes, the public reaction was nothing short of apocalyptic hysteria. Overnight, conspiracy theories flooded social media claiming that physicists were about to accidentally destroy Earth by creating an unstoppable gravitational monster that would devour the planet from the inside out. The panic reached such fever pitch that multiple lawsuits were filed in courts across Europe and America, with terrified citizens demanding immediate injunctions to halt the Large Hadron Collider's operations. News outlets sensationalized the story with headlines screaming about scientists playing God and the end of the world, hidden beneath Switzerland. Online forums exploded with amateur physicists and concerned parents sharing viral videos, explaining how a single microscopic black hole could theoretically grow by consuming surrounding matter until it swallowed the entire solar system. The fear wasn't entirely irrational. After all, we're talking about recreating one of the universe's most destructive phenomena in a laboratory setting. Protesters gathered outside CERN facilities holding signs reading, "Stop the Doomsday Machine," while petition websites crashed from millions of signatures demanding the project's cancellation. Religious groups declared it an affront to divine creation, while survivalists began stockpiling supplies for the impending apocalypse. The scientific community found themselves in the unprecedented position of having to calm global panic while simultaneously pushing forward with experiments that could revolutionize our understanding of reality itself. The cosmic ray reality check. While panicked crowds demanded CERN's shutdown, physicists delivered the most elegant scientific smackdown in history by simply pointing upward at the sky. Every single second of every single day, our planet gets bombarded by cosmic rays, high-energy particles from deep space that crash into Earth's atmosphere with energies that make CERN's collisions look like gentle bumper cars at a carnival. These cosmic bullets have been pummeling our planet for over 4.5 billion years, generating particle collisions with energies thousands of times more powerful than anything the Large Hadron Collider could ever produce. If dangerous, Earth-devouring black holes were actually possible at these energy levels, our planet would have been consumed eons before the first dinosaur ever walked the Earth. The Moon, with no protective atmosphere, takes these cosmic ray hits directly on its surface, yet it's still hanging peacefully in our sky after billions of years of constant bombardment. Scientists calculated that cosmic rays create the equivalent of millions of CERN-level collisions in our atmosphere every single day, and we're all still here, completely unharmed. This cosmic ray argument became the ultimate reality check that silenced most critics. Nature has been running the exact same experiment CERN was proposing, but on a vastly larger scale for literally billions of years. The universe itself had already proven that these high-energy collisions were completely safe, making the doomsday fears seem almost comically overblown. The actual experimental results. When the Large Hadron Collider roared to life for its first high-energy collisions, the entire scientific world held its breath as detectors captured data from the most violent particle crashes in human history. What happened next wasn't the apocalyptic black hole scenario that terrified millions. No, it was something far more extraordinary. The collisions revealed a hidden universe of subatomic particles that had been theoretical fantasies for decades, suddenly becoming measurable reality. Scientists watched in awe as their detectors registered the creation and immediate decay of exotic particles with names like strange quarks, charm quarks, and bottom quarks. Building blocks of matter so fundamental they only exist for microseconds before transforming into other particles. The most groundbreaking discovery came in 2012 when they finally detected the Higgs boson, the so-called God particle that gives all other particles their mass. This wasn't just a scientific victory, it was confirmation that our mathematical models of the universe were actually correct. Each collision produced cascades of data showing how matter behaves at the most fundamental level, revealing that the universe operates according to principles so elegant and precise, they border on the miraculous. Instead of creating world-ending black holes, CERN was uncovering the deepest secrets of existence itself, proving that sometimes the most terrifying experiments lead to the most beautiful discoveries about the nature of reality. The missing energy mystery. The most spine-tingling discovery at CERN wasn't what scientists found, it was what they couldn't find. During certain high-energy particle collisions, detectors registered something that honestly should have been impossible according to our understanding of physics. Energy was disappearing without a trace. Not just small amounts, but significant chunks of energy that should have been conserved according to the fundamental laws of the universe. Every collision should follow the ironclad rule that energy can neither be created nor destroyed, only transformed from one form to another. Yet here were collisions where the energy going in was measurably greater than the energy coming out, as if some invisible force was stealing it mid-collision. The missing energy wasn't random, it followed specific patterns that sent theoretical physicists into overdrive. The leading explanation is so mind-bending it sounds like science fiction. The energy is leaking into parallel dimensions through microscopic tears in space-time created during the most violent collisions. If this theory is correct, then CERN isn't just smashing particles together, it's accidentally punching holes between our universe and hidden dimensions that exist alongside our own reality. Each missing joule of energy could be proof that our three-dimensional world is just one layer of a vast multi-dimensional cosmos. This means every time energy vanishes at CERN, we might be witnessing the first direct evidence that parallel universes aren't just theoretical concepts, but actual places where our energy is escaping to through quantum tunnels we're only beginning to understand. The future implications. The potential ability to create and study quantum black holes at CERN represents far more than just another scientific achievement. It could be the key that unlocks technologies so advanced they would make our current civilization look, well, primitive by comparison. If scientists can reliably generate these microscopic gravitational anomalies, we're not just talking about understanding physics better. We're talking about harnessing the fundamental forces that govern reality itself. These quantum black holes could become the ultimate energy source, converting matter directly into pure energy with 100% efficiency, making nuclear power look like a candle compared to the sun. The implications for space travel are staggering. Imagine propulsion systems that manipulate space-time itself, allowing spacecraft to bend the fabric of reality and travel vast distances in impossibly short time frames. Even more mind-bending is the possibility of using controlled micro-black holes to access parallel dimensions, potentially opening doorways to alternate versions of our universe where the laws of physics might operate differently. The technology could revolutionize computing by creating quantum processors that operate across multiple dimensions simultaneously, solving problems that would take conventional computers millions of years to crack. We might even develop the ability to manipulate time itself, using the extreme gravitational fields of micro-black holes to create localized time dilation effects. This isn't science fiction anymore. It's the logical next step in human technological evolution, where we transition from merely observing the universe to actively reshaping it according to our will. The ongoing research. At this very moment, teams of physicists around the world are sifting through petabytes of collision data from CERN, searching for the telltale signatures of microscopic black holes that could rewrite our understanding of existence itself. Every single collision generates thousands of data points that must be meticulously analyzed by both human researchers and artificial intelligence systems designed specifically to detect anomalies that human eyes might miss. The search isn't random. Scientists know exactly what to look for: specific patterns of missing energy, unusual particle decay signatures, and gravitational effects that last for impossibly brief moments before vanishing completely. Advanced algorithms run 24/7, comparing actual collision results against theoretical predictions, flagging any events that deviate from expected outcomes. The most promising candidates undergo intense scrutiny, with teams of experts examining every microsecond of data to determine whether they've witnessed the birth and death of a quantum black hole. Recent upgrades to CERN's detection systems have increased sensitivity by orders of magnitude, allowing researchers to probe deeper into the quantum realm than ever before. Each new collision brings humanity closer to answering fundamental questions about the nature of reality. Are extra dimensions real? Can we create controlled tiers in space-time? Do parallel universes actually exist just beyond our perception? The answers to these questions aren't just academic curiosities. They could fundamentally transform our species' relationship with the cosmos and unlock technologies that seem impossible today. So there you have it. CERN might be creating microscopic black holes that could unlock the secrets of parallel dimensions and reshape our understanding of reality itself. The universe is far stranger and more incredible than we ever imagined. What's your take on this? Are we playing with forces beyond our control, or are we on the verge of the greatest scientific breakthrough in human history? Drop your thoughts in the comments below. I read every single one and love hearing your perspectives. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss our latest mind-bending science content. This is Simply Science, and I'll see you in the next video. What if humanity's first contact with alien technology already happened, and we almost missed it? In October 2017, a mysterious cigar-shaped object from deep space blazed through our solar system at 87.71 kilometers per second, faster than any natural object should move. Scientists called it Oumuamua, meaning scout from afar. But here's the kicker: this thing accelerated away from the sun without any visible propulsion, breaking every law of physics we know. Did you know that some Harvard scientists seriously believe we just witnessed our first alien spacecraft? Oumuamua initial detection. On October 19, 2017, the cosmos delivered humanity its first confirmed interstellar visitor, and Robert Warwick at the Pan-STARRS, one telescope in Hawaii, was the lucky astronomer to spot it first. But this wasn't your typical space rock discovery. Oumuamua was already 33 million kilometers away from Earth when we finally noticed it, traveling at speeds that, honestly, just screamed alien highway. The object had performed its closest solar flyby on September 9, 2017, coming within 38 million kilometers of our sun before we even knew it existed. Its hyperbolic trajectory told an incredible story. This visitor had traveled through the dark void between stars for potentially millions of years before stumbling into our cosmic neighborhood. The Hawaiian name Oumuamua means scout or messenger from afar arriving first, and boy did it live up to that name. What made this discovery earth-shattering wasn't just its interstellar origin. It was moving too fast for our sun's gravity to capture it permanently, meaning we had only a brief window to study this cosmic time capsule before it vanished back into the infinite darkness between stars. The detection itself was almost miraculous timing. Oumuamua was already on its way out of our solar system when spotted, having reached its perihelion weeks earlier. The astronomical community immediately recognized this as a once-in-a-lifetime opportunity to study pristine material from another star system, triggering an unprecedented international observational campaign. Within days of discovery, telescopes worldwide were trained on this mysterious visitor, desperate to gather as much data as possible before it faded beyond detection limits forever. Classification challenges. Scientists love putting things in neat categories, but Oumuamua laughed in the face of their organizational systems. Initially tagged as Comet C-2017-U1 due to its hyperbolic escape trajectory, astronomers expected to find the telltale fuzzy coma that forms when comets heat up near the sun. Instead, they found absolutely nothing. No gas, no dust, no glowing halo whatsoever. This forced an immediate reclassification to asteroid A-2017-U1, but even that didn't stick. Once confirmed as definitively interstellar in origin, it earned the historic designation 1I-2017-U1, literally the first official member of an entirely new category, interstellar objects. This classification nightmare reflected something deeper and more unsettling. Oumuamua didn't behave like any known comet or asteroid in our solar system. It was forcing scientists to create new categories because existing ones simply couldn't contain its strangeness. The International Astronomical Union had to scramble to establish naming conventions for objects that, until 2017, existed only in theoretical papers. This classification chaos was just the beginning of Oumuamua's assault on conventional astronomical wisdom, setting the stage for discoveries that would challenge everything we thought we knew about how objects behave in space. The unprecedented situation required emergency sessions among astronomical organizations to establish proper nomenclature protocols. Minor Planet Center Director Gareth Williams worked around the clock to coordinate the classification process, while researchers debated whether traditional comet-asteroid distinctions even applied to interstellar visitors. The object's refusal to fit existing categories forced a fundamental reimagining of how we classify celestial bodies, acknowledging that our solar system's objects might represent just a tiny fraction of the diversity that exists in interstellar space. Trajectory analysis. When Oumuamua entered our solar system, it didn't follow any ordinary orbital mechanics playbook. This interstellar intruder approached from north of the ecliptic plane at an extreme angle, suggesting it originated from the direction of the bright star Vega in the constellation Lyra. As it screamed toward the sun, Oumuamua accelerated to an absolutely mind-bending 87.71 kilometers per second, fast enough to circle Earth's equator in just over 7 minutes. The sun's immense gravitational field acted like a cosmic slingshot, bending the object's trajectory into a sharp northward curve during its closest approach at 0.255 astronomical units, approximately 17% closer to the sun than Mercury ever ventures. This gravitational dance launched Oumuamua on an escape trajectory toward the constellation Pegasus, ensuring it would leave our solar system forever. But here's what made trajectory analysts lose sleep. The object's path showed subtle deviations that couldn't be explained by gravitational forces alone. These tiny but measurable course corrections suggested something was pushing Oumuamua in ways that defied Newton's laws. The trajectory data painted a picture of an object under the influence of mysterious forces that would later become the center of heated scientific debates about alien technology versus exotic natural phenomena. Detailed orbital calculations revealed that Oumuamua had likely been wandering through interstellar space for hundreds of millions of years before its chance encounter with our solar system. The object's orbital eccentricity of approximately 1.2 marked it as definitively unbound to our Sun, while its inclination of about 122 degrees indicated it was traveling nearly perpendicular to the plane of our solar system. NASA's Jet Propulsion Laboratory continuously refined trajectory predictions as new observations poured in, but the mounting evidence of non-gravitational forces would soon turn routine orbital mechanics into one of astronomy's greatest puzzles. Photometry and shape analysis. Nothing had prepared astronomers for Oumuamua's absolutely bizarre light curve behavior. As this cosmic enigma tumbled through space with a 7.3-hour rotation period, its brightness varied by an unprecedented factor of 10, meaning it alternated between being 10 times brighter and 10 times dimmer as it spun. No known asteroid or comet in our entire solar system exhibits such extreme brightness variations. The only way to explain this dramatic light show was if Oumuamua possessed an incredibly elongated shape, possibly 10 times longer than it was wide, resembling a cosmic cigar or needle. Some models suggested even more exotic geometries, with dimensions potentially reaching 240 meters wide by 1,080 meters long, or alternatively, a pancake-shaped object of similar proportions. The Spitzer Space Telescope observations provided crucial constraints, indicating the object's surface was surprisingly reflective, about 4 times more reflective than typical asteroids. This high albedo suggested either an unusual composition or a surface coating of some kind. The extreme aspect ratio challenged everything scientists understood about how celestial bodies form and evolve. Natural processes typically create relatively spherical objects due to gravitational forces, yet Oumuamua appeared to violate these fundamental principles. Its shape was so unusual that some researchers began seriously considering whether natural formation processes could even produce such an object, opening the door to more exotic explanations. Acceleration anomaly. June 27, 2018 marked the day that Oumuamua officially broke physics, or at least appeared to. Marco Michelli and his team published observations showing that this interstellar visitor was accelerating away from the Sun in a way that gravity alone couldn't explain. The non-gravitational acceleration was subtle but undeniable, changing the object's velocity by approximately 17 meters per second over the observation period. For any normal comet, this would be easily explained by outgassing, when solar heat vaporizes ice, creating jets that act like tiny rocket engines. But Oumuamua had already proven it wasn't normal by showing zero signs of a coma or tail. The acceleration was detected through precise astrometric measurements that tracked the object's position against background stars with incredible accuracy. The force appeared to be acting radially away from the Sun, similar to solar radiation pressure, but Oumuamua would need to be impossibly lightweight or have an impossibly large surface area for photons alone to push it around. This discovery sent shockwaves through the astronomical community because it suggested either exotic physics or exotic origins. The acceleration magnitude was tiny, about 5 times 10 to the minus 6th meters per second squared, but measurable enough to rule out observational error. Scientists found themselves facing an object that was simultaneously too dense for radiation pressure and too inactive for typical cometary outgassing, creating a perfect storm of confusion. Spitzer observations. The Spitzer Space Telescope became humanity's detective in the case of the missing Oumuamua. During November 2017, this infrared space observatory stared at the object's predicted location for over 30 continuous hours, searching for any thermal emission that would reveal its true size and composition. The result? Absolutely nothing. This non-detection wasn't a failure, it was actually a goldmine of information that deepened the mystery exponentially. Spitzer's inability to see Oumuamua placed strict upper limits on the object's thermal emission, which in turn constrained its size to no larger than 440 meters in its longest dimension, assuming typical asteroid-like properties. More importantly, the lack of detectable heat signature ruled out significant amounts of carbon monoxide, carbon dioxide, and dust production, the typical calling cards of active comets. This observation was crucial because it eliminated many conventional explanations for the mysterious acceleration. If Oumuamua wasn't producing detectable amounts of gas or dust, then what invisible force was pushing it around? The Spitzer data also suggested the object's surface temperature was consistent with a dark, possibly organic-rich composition, similar to the outer solar system objects. Yet this composition didn't match the high reflectivity observed at visible wavelengths, creating another layer of contradiction. The telescope's failure to detect the object directly contributed to size estimates and ruled out many exotic composition theories. but it also eliminated easy explanations for the acceleration anomaly, pushing scientists toward increasingly creative theoretical solutions. Artificial origin hypothesis. Abraham Avi Loeb, Harvard's controversial astrophysicist, dropped a bombshell that sent ripples through both scientific circles and popular media. In his 2018 paper and subsequent 2021 book Extraterrestrial, Loeb argued that Oumuamua's unique characteristics, its extreme elongated shape, unusual reflectivity and mysterious acceleration, could only be satisfactorily explained if it were an artificial object created by an alien civilization. Specifically, Loeb proposed that Oumuamua might be a light sail, which is, an ultra-thin sheet of material designed to be pushed by stellar radiation for interstellar travel. This technology, while still theoretical for humans, could explain both the object's extreme thinness, giving it that unusual aspect ratio, and its acceleration away from the sun via solar radiation pressure. The hypothesis suggested we might have witnessed discarded alien technology or even an active probe sent to investigate our solar system. Loeb's argument wasn't based on wild speculation but on systematic elimination of conventional explanations. He calculated that for solar radiation pressure to account for the observed acceleration, Oumuamua would need to be incredibly thin, perhaps only millimeters thick, which could occur naturally only under the most extraordinary circumstances. The artificial origin hypothesis sparked fierce debate, with most astronomers maintaining that extraordinary claims require extraordinary evidence. However, Loeb's rigorous mathematical approach forced the scientific community to seriously consider possibilities that had previously been relegated to science fiction, fundamentally changing how we approach anomalous observations. Dark comet theory. Enter the dark comet theory, the scientific community's attempt to rescue Oumuamua from alien conspiracy theories while still explaining its impossible behavior. Alan Fitzsimmons and his colleagues propose that Oumuamua represents a new class of object comets that have been so heavily processed by cosmic radiation and interstellar weathering that they've lost their ability to produce visible comas and tails. The theory suggests that during its millions-year journey through interstellar space, Oumuamua was bombarded by high-energy particles that altered its surface composition and internal structure. This processing could have created a carbonaceous crust that insulates the interior while still allowing subtle outgassing of invisible materials like hydrogen gas. In 2023, Jennifer Bergner and Daryl Seligman published groundbreaking research showing that cosmic ray bombardment of water ice can produce trapped molecular hydrogen that later escapes when heated by the sun. This hydrogen outgassing would be completely invisible to telescopes, but could generate enough force to explain the observed acceleration. The beauty of this theory is that it explains not just the acceleration anomaly, but also why Oumuamua appeared so different from familiar comets. The dark comet model suggests that interstellar space is filled with these ghostly, processed remnants of ancient planetary systems. Objects that look dead but retain just enough activity to push themselves around when they encounter a star's heat and light. Dark comet classification. The dark comet classification emerged as astronomers realized that Oumuamua might not be unique, but rather the first detected member of an entirely new category of celestial objects. These dark comets are defined as objects that exhibit non-gravitational acceleration, the smoking gun of outgassing activity, without displaying any visible signs of cometary behavior like comas, tails, or dust production. The classification system divides these mysterious objects into categories based on their size and orbital characteristics. Large dark comets like Oumuamua follow hyperbolic trajectories and likely originate from interstellar space, while small dark comets remain gravitationally bound within our solar system. Recent discoveries have identified several potential dark comet candidates within our own solar system, including objects like 2003 RM and 2005 VL1, which show subtle acceleration signatures without obvious cometary activity. The classification represents a fundamental shift in how astronomers categorize solar system objects, acknowledging that the traditional asteroid-comet dichotomy is insufficient to describe the full diversity of objects in space. Dark comets challenge our understanding of planetary formation and evolution, suggesting that the boundaries between different types of celestial bodies are far more fluid than previously believed. This new classification system also has profound implications for planetary defense strategies, as dark comets might be more difficult to detect and track than traditional objects, yet their unpredictable acceleration could alter their trajectories in unexpected ways.
Scientific debate.
The scientific community remains locked in a fascinating intellectual battle over Oumuamua's true nature, with competing theories each addressing some aspects of the mystery, while leaving others unexplained. The mainstream scientific consensus, established by July 2019, favors natural explanations, with the hydrogen outgassing model gaining significant support following Bergner and Seligman's 2023 research. This theory elegantly explains both the acceleration and the lack of visible outgassing through cosmic ray processing of interstellar ice. However, alternative explanations persist, including nitrogen ice composition models proposed by Alan Jackson and Stephen Desch, which suggest Oumuamua might be a fragment of a Pluto-like exoplanet. The artificial origin hypothesis championed by Avi Loeb continues to attract attention despite mainstream rejection, particularly given the lack of definitive proof for any natural explanation. Some researchers propose even more exotic scenarios, including dust bunny models where Oumuamua could be an extremely low-density aggregate held together by electrostatic forces. The debate has highlighted crucial gaps in our understanding of interstellar object formation and evolution. The upcoming Vera Rubin Observatory, scheduled to begin full operations in the mid-2020s, promises to detect hundreds or thousands of similar objects, potentially providing the statistical sample needed to resolve the debate. Meanwhile, ESA's proposed Comet Interceptor mission could potentially visit another interstellar visitor if one arrives at the right time. The scientific controversy surrounding Oumuamua has already advanced our understanding of solar system formation, interstellar space conditions, and the importance of rapid response observations for transient celestial phenomena, regardless of which theory ultimately proves correct. That's the incredible story of Oumuamua, our first confirmed interstellar visitor that continues to challenge everything we thought we knew about space. From its mysterious acceleration to its impossible shape, this cosmic enigma proves that the universe still holds secrets we're only beginning to understand. What do you think Oumuamua really was? Natural phenomenon or something more extraordinary? Drop your theories in the comments below. I'd love to hear your thoughts. If you enjoyed diving into this cosmic mystery, hit that subscribe button and ring the bell icon to never miss another mind-bending episode from Simply Science. Until next time, keep looking up,